Okay, so we're going to look at some examples where we have to change some polar equations to Cartesian so that we'll be able to identify the type of graph that we are dealing with. Okay, so to begin with, let's say we have r being equals to 4 cosec theta. Okay, how do we change this? So the first thing that you do is that try to write it in a manner that you are familiar with. Remember to say if we want to find x, okay, x is basically r cos theta. Okay, then your y is r sin theta. Okay, so you'd want to ensure that you are you are dealing with sine as well as cos. So whatever you have, try to convert it in that form using the trig identities. Okay, so what I have here is a cosec. So I know that from trig identities, my cosec theta is basically equals to 1 over sine theta. Okay, so here I'm saying my r is equals to my 4 over sine theta. So what you're going to have is that your 4 will be equals to your r sine what? Sine theta. And we know that r sine theta is what? Is y. So we can say our y is basically equals to a 4, which is just a straight line that is cutting the y-axis at positive 4. So that's the graph that we are dealing with on that one. Okay, so let's try to look at something else. Let's say we are given r squared to be equals to 4 for r sine 4r sine theta. Okay, how do we change that to Cartesian and being able to identify the graph? Okay, so we know what our r squared is. Our r squared is basically equals to y squared plus x squared. This is what our r squared is. This comes from this is where you have your y here, your x here, and you have your r there. Then using Pythagoras theorem, uh, this is what we come up with. So instead of us using r squared, we are going to use x squared plus y squared is equals to 4. Okay, 4. What is this part? This part is a y, so this is 4y. Okay, so what we have is x squared plus y squared minus 4y is equals to 0. So what we need to do in this case is that we can try to identify the type of conic that we're dealing with just from this point. We can try to break it down further, but I prefer trying to break it down so that I'll be able to really see clearly what I'm dealing with. But if you'd want, you can use the discriminant test to try to find out what this is. So if you were to try to use the discriminant test, okay, if you try to use the discriminant test on this one, um, remember to say your b squared minus your 4ac is equals to some value, and when it is greater than 0 is a hyperbola, when it's less than 0 is an ellipse, when it's equals to 0 is the parabola. Okay, uh, so our b is basically the xy term, and we don't have an xy term, so b is 0 minus 4. Our a is 1, our c is the so here I'm getting the 1 from the coefficient of x. Okay, a is the coefficient of x, c is the coefficient of y, of which is also 1 here, is equals to some value. So here what you're going to have is negative 4. So we now know to say our discriminant for b squared minus 4ac is what? Is less than 0, which is what? Which is an ellipse. But what I would want to do is I would want to try to break down the equation that I have so that I really know what I'm dealing with, because sometimes it can be, of course it can be an ellipse, but remember to say a circle is also an example of an ellipse. So what you do here is that I need to complete the square for y. So I'm going to have x squared here, we'll say plus open bracket y squared minus 4y plus minus 2 squared minus 2 squared, we close. Okay, so that would be x squared, that would be x squared there. We're going to say plus open bracket y minus minus a 2 there, we say squared minus positive 4. Okay, so this is equals to 0. So I'm saying our x squared plus to be y minus 2 squared is equals to positive 4. So dividing both sides by positive 4, like that, we are going to have our x squared over 4 plus our y minus 2 squared divided by 4, giving us what? Giving us a 1. And we can clearly see that our a squared value, our a squared value is equals to 4, and our b squared value is equals to what? Is also equals to 4, meaning the c squared value is going to be equals to what? 0, meaning even c is equals to 0, making the eccentricity to be what? 0, because we are saying it's c divided by a. We are simply saying 0 divided by a 2, which is still what? A 0. And the conic that has eccentricity 0 is basically what? Is basically a circle. So that's why I said it's also very important that we try to break it down further so that we really know the kind of conic that we are dealing with, because a circle to some cases is an example of an ellipse. So that's how you go about that question. So let's try to look at perhaps the last example, or something that is a bit complex. So let's say we have r squared plus 2 2r squared cos theta sin theta is equals to 1. So this can also be written as r squared plus um, r squared sin 2 theta is equals to 1. It's one and the same thing. So if you find it like this or find it like this, it basically means one and the same thing. It's just some trig identities that we have here. We say our sine 2 theta is equals to our 2 cos sine theta, or 2 sine cos theta, meaning one and the same thing. So what do you do in this case? Of course, we need to do the conversion, and we know what r squared is. R squared is x squared plus y squared plus. Then what I would want to do here is that I'll distribute the r to cos and to sine. So meaning I'm having 2 r cos theta, then r sine theta here is equals to 1. Okay, this is basically one and the same thing. So we're going to have our x squared here plus y squared plus 2. My r cos theta is what? Is x. Then my r sine theta is what? Is y. Equals to what? Equals to 1. So we have an equation there that having if we were to write this in the proper using the proper format, we're going to have our x squared plus 2xy plus y squared minus 1 is equals to what? Is equals to 0. So here, no need of sketching. The question is just asking us to identify the graph. Of course, we've already done the convention. What you need to do is to identify the graph. So we can use the discriminant test at this point to identify the graph. So we have our b squared minus 4ac is equals to some value here. I'll just say a question mark there, we don't know yet. So we are going to say our b is the xy term, and the b that we have is what? Is a 2 squared minus, so 4 multiplied by a multiplied by c. Our a is the coefficient for x, our c is the coefficient for y. So we're going to have a 1 by 1 there is equals to some value. So this will be 4 minus 4, giving us a 0. And we know from the discriminant test, if the value of the discriminant is equals to 0, we are dealing with a parabola. If it's less than 0, we are dealing with an ellipse. If it's greater than 0, we are dealing with a hyperbola. So this is basically what? A parabola. Okay, this is basically a parabola that you are dealing with there. So when you're dealing with such questions, they can appear to be a bit maybe complex. It's just a matter of knowing the relationship between r and or cos, the sine, or anything that you are dealing with. They can give you such as sec theta, they can give you tan theta, they can give you cot theta, cosec theta, anything, but just try to express it in the form that you are okay to use. Alright, so that's how we go about answering that question. Thank you very much for watching.